Hey guys, in this video I'm going to run you through all the solutions for 2023 AS Paper 1. Every question is going to be timestamped so you can easily find the solution to a particular question. Hope you find this video helpful. So here's the front of the paper. If we scroll straight ahead to question 1, it says, at a point P on a curve, the gradient of the tangent to the curve is 10. State the gradient of the normal to the curve at P. Well, the normal is the line that's perpendicular to the tangent. So we just think about what we know about the gradients of perpendicular lines. The negative reciprocal is what we'll do to get the perpendicular gradient to the tangent. So that would be minus 1 over 10, which would just be minus 0.1. Then it says identify the expression below, which is equivalent to 2x over 5 all to the power of minus 3. But to simplify that quickly first, we can make it to the power of 3 if we just flip the fraction. So that'd be the same as 5 over 2x all cubed. And then if we just cube that whole expression, 5 cubed is 125, and then 2x cubed is 8x cubed. So it'd be 125 over 8x cubed. Moving on now to question 3. It says the coefficient of x squared in the binomial expansion of 1 plus ax all to the 6 is 20 over 3. Find the two possible values of a. So first let's start by using a binomial expansion formula to get an expression for the x squared term of that expansion. So 1 plus ax all to the 6. Using our formula, that would be 1 to the 6 plus 6, choose 1 to the 5 times ax to the 1 plus the term we're actually interested in, so 6 choose 2, 1 to the 4, and then ax all squared. And that would go on, but we'll stop there because I'm only interested in that quadratic term. So 6 choose 2 if we use our calculator quickly. That's 15. And then 1 to the 4 is just 1, so we'll forget about that. And then ax all squared is a squared x squared. So the quadratic term, the squared term of our expansion is 15a squared x squared. But we know the coefficient, 15a squared, must equal 20 over 3. And now if we solve for a, first we get a squared is 20 over 45. And that simplifies, if we divide both top and bottom of the fraction by 5, that would be 4 over 9. And then square rooting that, making sure we do plus or minus, that's where our two solutions come from, we get plus or minus 2/3. Moving on now to question 4. It says, it is given that 5 cos squared theta minus 4 sine squared theta equals 0. Find the possible values of tan theta, giving your answer in exact form. Well, to start thinking about tan theta, we know there's an identity that tan theta is identically equal to sine theta over cos theta. So we want to start dividing by cos thetas, really, if we want to introduce tan thetas. So if we divide everything by cos squared theta, that's going to go very nicely for us. So if we divide everything by cos squared theta in that equation, we'd be left with 5 minus 4 sine squared theta over cos squared theta equals 0. And then sine squared theta over cos squared theta is just this identity squared, so it's just tan squared theta. So that would be 5 minus 4 tan squared theta equals 0. So then if we rearrange, we'd have tan squared theta equals 5 over 4. And then if we square root, we'd have tan theta is plus or minus root 5 over 2. Now it says, hence or otherwise, solve the equation 5 cos squared theta minus 4 sine squared theta equals 0. Giving all solutions of theta to the nearest 0.1 degree in the interval of 0 to 360 degrees. So we've got to solve basically these two equations we've deduced here. So we've got this to work with, tan theta equals positive root 5 over 2, and tan theta equals minus root 5 over 2. Let's start with the first one on the left. So if we get our first solution from our calculator, so go to inverse tan of the square root of 5 over 2. That's at 48.1896. And if you draw yourself a little picture to look at what the tan graph looks like, we know all the solutions repeat every 180 degrees to get to the same point on the tan graph. So our first solution is just that, is theta equals 48.189, which to point to the nearest point 1 will round to 48.2 degrees. And then to get the next solution, I can just add 180 degrees because the tan graph repeats every 180 degrees. So that's 228.18, and rounding to 0.1 again, that would be 228.2. And that would be the last solution for that equation, because if I add another 180, I would go beyond 360. Then let's look at the second solution. So tan theta is minus root 5 over 2. Let's get our first solution for that. So we'll do inverse tan of minus root 5 over 2. And we just get, due to the symmetry of the graph, we just get the same number but negative. That first solution isn't actually in our interval that they've asked for, but we can apply the same trick and just add 180 as many times as we can to gather all the solutions we are interested in. So if we add 180 once to that, we have 131.8 degrees to the 0.1 degree rounding. So we get theta equals 131.8 degrees. And then I can actually add 180 one more time and stay inside the interval, which gives us 311.8 degrees. And that would be the final solution, because if I add 180 again, I'd be beyond 360 degrees and outside the interval. Moving on now to question 5. 5a says, given that y equals x root x, find dy dx. So we're just going to use the power rule. Let's express it as a single power of x to start off with. So if y equals x root x, we know that's the same as x times x to the half, which is just using the multiplication rule for indices. We just add the powers, so x to the 1 times x to the half. That would give us x to the 3 over 2, which means, using the power rule for differentiation, we'd have dy by dx would be 3 over 2 x to the power of a half. Part B then says the line L has equation 6x minus 2y plus 5 equals 0. L is a tangent to the curve with equation y equals x root x plus k. Find the value of k. Well, the first thing is, a piece of information we've got is that it's a tangent. So let's find the gradient of this line by re-expressing it in terms of y equals mx plus c. So let's do that first. So if I bring the 2y over, I would have 2y equals 6x plus 5. Then dividing everything by 2, we'd have y equals 3x plus 5 over 2. Now, this curve would have the same derivative as the curve we did earlier, because a constant k would differentiate to 0. So we're looking for a point on this curve where the gradient is 3. So let's just sub that in for the gradient of the tangent, sub it in for dy by dx. So we know dy by dx is equal to our expression from earlier, 3 over 2 x to the half. But let's just plug in what we know the value of dy by dx to be also, which is 3 from our straight line. And now let's solve this equation. So 3 over 2x to the half equals 3. Let's first let's divide everything by 3 and then multiply by 2. So if I divide by 3 first, I'd have a half x to the 4, x to the half, excuse me, would just equal 1. Then we'd have, if I multiply by 2, I'd have x to the half equals 2. Then squaring both sides, I would get x just equals 4. And now, if we want to find this constant k, I'm going to need an x and a y coordinate to lie on there. But as L's a tangent, the point where it's a tangent, that point lies on both the line and the curve. So we can plug the x value we know into L, and it will have the same y coordinate for both the line and the quadratic. So let's do that. So if I use this form, plugging in x equals 4, we'd get y equals 3 times 4 plus 5 over 2. I'm just going to do that quickly on a calculator. So 3 times 4 plus 5 over 2, we get 29 over 2. So y is 29 over 2. Now we can sub that in to our equation for the curve to find k. So y is 29 over 2. And then x is 4, so we have equals 4 times the square root of 4 plus k. And then 4 times the square root of 4, well, root 4 is 2, 4 times 2 is 8. So we have 29 over 2 plus 8, equals 8 plus k. And then if we just subtract 8 from that, so 29 over 2, subtract the 8, we get 13 over 2 for k. Moving on now to question 6. 6a says the curve C1 has equation y equals 2x squared minus 20x plus 42. Express the equation of C1 in the form y equals a times x minus b all squared plus c, where a, b, and c are integers. So we need to just complete the square, basically, is what it's asking. So let's just start by writing our quadratic. So we've got y equals 2x squared minus 20x plus 42. Whenever the coefficient of the squared term is not 1, I'll take out the coefficient as a factor from the whole equation. So we'd have y equals 2x squared minus 10x plus 21. Now complete the square normally for that term in the terms inside the bracket. So that would be equal to 2 still there. We'd have x minus 5, halving that x coefficient for the bracket. Then if I squared that back out, I would get the x squared and the minus 10x, but I'd also get a plus 25, which I don't want. So we'll take away 25, and then we need the plus 21 still, so I'll add the 21 back in. So that would be 2 lots of x minus 5 all squared, and then minus 25 plus 21 is minus 4. And then expanding out the big bracket, we'd have 2 lots of x minus 5 all squared, and then minus 8 for the 2 times the minus 4. Next it says, write down the coordinates of the minimum point of C1. Well, completing the square tells us that very nicely, because if you think about graph transformations, I won't go into that now, but basically minus 5 is going to give us the x-coordinate. That means the x-coordinate is positive 5. And the y-coordinate comes from the minus 8, and it just will be minus 8. Okay, and then we've got the curve C1 is mapped onto a curve C2 by a stretch in the y direction. The minimum point of C2 is at 5 minus 4. Find the equation of C2. Well, a stretch means we're multiplying the y-coordinate by a number. Specifically, if we're going to go from minus 8 to minus 4, we'd be multiplying by a half. And then in function notation, so that would be y equals a half of f of x. So we're simply going to take our old function and multiply it by a half. So y equals a half of everything we had before, 2 lots of x minus 5 squared minus 8, and that's simple to expand through, so that's just going to cancel the 2, so we just have x minus 5 squared and minus 4. Moving on now to question 7. It says the points P and Q lie on the curve with equation y equals x to the 4. The x-coordinate of P is x, and the x-coordinate of Q is x plus h. So this instantly looks like it's going to lead into a differentiation from first principles question from the use of that term h. But part A just says, can we expand x plus h to the power of 4? So I'm going to do that with the binomial expansion. So x plus h to the 4, starting off just by writing out the formula, that would be x to the 4 plus 4 choose 1, x to the 3, h to the 1, plus 4 choose 2, x to the x squared times h squared, plus 4 choose 3 times x squared, x to the power of 1, h cubed, plus the final term just all to the power of 4, so just plus h4, h to the 4. Then if we simplify that down, we would have x to the 4, 4 choose 1 is just 4, so 4 times x cubed times h, so that's 4 x cubed h. 4 choose 2, I will quickly check on my calculator. 4 choose 2 is 6. So we'd have 6 x squared h squared. 4 choose 3 is 4 again. So that's going to be 4x h cubed, and then the last term is still just h to the 4. Then it says, hence find an expression in terms of x and h for the gradient of the line PQ. So to get the gradient of a straight line, just the rise over the run. And what we've calculated here actually is the y-coordinate when we sub in x plus h into our function. So that's the y-coordinate of PQ. So let's just simply plug that in. So x to the 4 plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the 4, and then we take away the y-coordinate for our point P, which we get if we plug x into this, we just get x to the 4. So take away x to the 4, and then divide by the run, which is h, because it's h long from x. So that would simplify, we just have these x to the 4 terms cancel. And actually the power of h will cancel from everything as well. So that h would go, leaving that as h cubed, that would be h squared, and that would be a single power of h, and this h would disappear altogether. So that would be all equal to 4x cubed plus 6x squared h plus 4x h squared plus h cubed. Then for part C, it says explain how to use the answer from part B to obtain the gradient function. So the gradient function is the actual tangent, the derivative, right, of the original curve. So if we remember, the equation for differentiation from first principles is f dash of x is the limit as h tends to 0 of f of x plus h minus f of x all over h, and this is just what we calculated in part B. That's just the equation for, or the expression rather, for the gradient of the line PQ. So we really just need to take the limit as h tends to 0 of our expression from before. So 4x cubed plus 6x squared h plus 4x squared h squared plus h cubed. And we can see if we took the limit of that as it went to as h tends to 0, all these final terms right here with an h in would go to nothing, and we just be left with the 4x cubed. So that would be 4x cubed. Moving on now to question 8, it says, show that the integral from 1 to a of 6 minus 12 over the square root of x dx is equal to that expression in terms of a. So we just need to do this integral basically. Let's start by just converting that 12 over root x to a power of x. So our integral then would be the integral from 1 to a still of 6 minus, it would be 12x to the minus half to get 1 over the square root of x. So let's actually do the integral now. That would be 6 would integrate to 6x. So 6x. And then raising the power by 1 on the x term, that would be x to the half. And dividing by 12 by a half, we'd get 24. So it would be minus 24 x to the half. And then need to plug in our limits. So let's start with plugging in the a. We'd have, writing this all as a new line, let's say be 6a minus 24 root a, all minus 6 times 1, which is just 6, minus 24 times the square root of 1, which is just 1, so minus 24. So then we just have 6a minus 24 root a, and then inside that bracket, 6 minus 24 is minus 18, and then minus minus 18 is the plus 18, so we get our final answer. So moving on now to part B of question 8, it says the curve y equals 6 minus 12 over root x, so that's the same as the curve we integrated a moment ago. The line x equals 1 and line x equals a are shown in the diagram below. So the integral we did effectively is for this shaded area that we've got. The shaded region R1 is bounded by the curve, the line x equals 1 the x-axis, and then, yeah, it's just describing the image. It is given that the areas of R1 and R2 are equal. So that's really important. Can we find the value of a? Fully justify your answer. So if the areas of R1 and R2 are equal, and R1's all below the x-axis and R2 is above the x-axis, that means if we integrate over the whole area, the positive and negative areas will cancel out to 0. So the expression we found earlier for that area actually needs to sum to 0. So 6a minus 24 root a plus 18 must equal 0. Plus 18. And that's actually a quadratic in disguise. If we set, let's say, u equal to the square root of a, this is 6u squared minus 24u plus 18 equals 0. And then to solve that, let's simplify. So the whole equation is actually divisible by 6, which is quite nice. So let's do that. Dividing everything by 6, we get u squared minus 4u plus 3 equals 0. And that factorizes quite nicely, so I'll just do that to solve. That's u minus 3 and u minus 1 equals 0. So u equals 1 or 3. And if we think, well, u is the square root of a, so if the square root of a is 1, that would mean a would equal 1, or a would equal 3. Sorry, 9, excuse me, to square the u value to get the a value, so 1 or 9. Well, it says only one value, not plural, in the question. So one of these solutions must be wrong. And if we think about it, if a was 1, then it wouldn't be an area at all. It would be an integral from 1 to 1, which would still give 0 if we ran it through the integral. So it makes sense we got that, but it doesn't make sense in our picture. So we can forget about that value. And the solution they're interested in is just a equals 9. Moving on now to question 9, it says a continuous curve has equation y equals f of x. The curve passes through the points A with coordinates 2, 1, B coordinates 4, 5, and C coordinates 6, 1. It is given that f dash of 4 equals 0. So 4 is the x-coordinate of B. So there must be some kind of stationary point at B. Jasmine made 2 statements about the nature of the curve y equals f of x at the point B. There is a turning point at B, and statement 2, there is a maximum point at B. So she could be correct. We don't really have enough information, but what's the actual question? Draw a sketch of the curve y equals f of x such that statement 1 is correct and statement 2 is correct. So assuming she's correct, our picture is just going to do what she described, basically. There's a turning point at B, which is also a maximum. So it would just have to be something like this. 9b then says, draw a sketch of our function such that statement 1 is correct. So it is a turning point. So it has to be a maximum or minimum. But statement 2 is not correct. So it's a turning point, but it's not a maximum, meaning it must be a minimum. So some smooth curve that goes through A, B, and C with specifically a minimum at B. Well, let's say we start here, we could go above perhaps and make that a minimum like that and go back up and then come back down to get to C. Then part C says draw a sketch of the y of our function such that statement 1 is not correct and statement 2 is also not correct. So statement 1 says it's a turning point. Well, it has to be a stationary point. If it's not a turning point, then it must be a point of inflection. And if we make it a point of inflection, statement 2 is also going to be incorrect. So that will work fine for us. So a curve that goes through A, B, and C, and at B we have a point of inflection. So let's draw something like this. So we go up, and then an inflection point through B, and then we can just have another maximum later on to get back down to C. Moving on now to question 10. It says, Charlie buys a car for £18,000 on the 1st of January 2016. The value of the car decreases exponentially. The car has a value of £12,000 on the 1st of January 2018. Charlie says because the car has lost £6,000 after 2 years, after another 2 years it will be worth £6,000. Kaya says because the car has lost 1/3 of its value after 2 years, after another 2 years it will be worth £8,000. Explain whose statement is correct, justifying the value they have stated. So Charlie's wrong, because that's not how exponentials models work. Kai is correct, because the proportional change over the same time period will be the same for an exponential model. So to put that into practice, if we lose 1/3 of the value from 18,000... So timesing by 2/3. Sorry, if you want to lose 1/3, that does give 12,000. And then just to check how number comes out, if we times 12,000 by another 2/3 to lose another 1/3 of the value, that does give 8,000. So we'd say Kai is correct because that's how exponential models work, or that's a property of exponential models. Okay, then it says the value of Charlie's car in V pounds T years. Always important to look at the units when you have a model. After the 1st of January 2016 may be modeled by this equation, where A and K are positive constants. Find the value of T when the car has a value of £10,000. Giving your answer to 2 significant figures. Well, to find that, we're going to need to have a completed model. So we need to find values of A and K. So A is simple. That's just always, for an exponential model, that's the starting value. So to demonstrate that's true. If you plug in t equals 0, you get e to the 0, and v will just equal a. So the starting value, which is defined from the unit, so t years after the 1st of January 2016, well, that's what we got earlier, so that's £18,000. So v of 0 is equal to a, which we know from before is £18,000. Then to get k, we have another piece of information. We know that the value 2 years on, so that's when t equals 2, is £12,000. So v of 2 is 12,000. So let's see what that tells us to find k. Well, we know 12,000 equals 18,000 e to the minus k times 2, so 2k. And then simplifying that, we'd have e to the minus 2k would equal 12,000 over 18,000, which is 12 on 18, or it's simply 2/3. So to solve that, we're going to need a logarithm. So minus 2k would be the natural log of 2/3. So then k would be equal to minus a half the natural log of 2/3. So I'll put that value in my calculator, ready for later. So let's do that. Minus 1 over 2 natural log of 2 over 3. That's equal to that number there. We'll just keep that ready for when we need it. Now the question wants, can we find the value of time t when the value of the car is £10,000? So we're setting the value to £10,000. So 10,000 equals 18,000 e to the minus kt, and we were trying to solve for t. We have k, we'll use that from our calculator in a minute. So first dividing by 18,000, 10,000 divided by 18,000, well, that'd be the same as 10 on 18, which would be the same as 5 on 9. So e to the minus kt is equal to, 5 over 9. Then t would equal, let's do it in steps actually, so minus kt would be the natural log of 5 over 9. And then we'd have t, the answer we're interested in, is minus 1 over k times the natural log of 5 over 9. So we have k stored here, so let's just use the answer button. So scrap that, minus 1 over our k, which was our answer, times the natural log of 5 over 9. Gives us 2.899 years. And how do they ask for the value? They said find the value of t to 2 significant figures. So if we ran to 2 significant figures, that would just be 2.9. Then 10c says, give a reason why the model in this context will not be suitable to calculate the value of the car when t equals 30. Well, if they ever say for a particular value, I would say it's always worth plugging in the value into the model. So let's do that. What is the value when t equals 30? So v is 18,000 e to our value of k from before times 30. So let's grab our value of k again. That was just minus 1 over 2 natural log of 2 on 3. So we've got that ready again. Plugging that in now, so we'd have 18,000 times e to the power of minus our answer times 30, which gives 41.1 pounds. So that's a pretty unrealistic cost or value of a car. You'd always scrap a car before you try to sell it for £40. So that's an unrealistic value, shall we say. And as an extra thing, the scrap value would be more. Moving on now to question 11. 11a says, a circle has equation x squared plus y squared minus 10x minus 6 equals 0. Find the center and the radius of the circle. So we need to put it in the nice form for a circle by completing the square. So completing the square for the x terms, we'd have x minus 5 all squared. If I were to expand that, I'd get the x squared and the minus 10x, but I'd also get a plus 25, which I don't want. So let's subtract away 25. And then the y squared doesn't actually have a y term, so we can leave that alone. And then there's a minus 6, so to put the minus 6 in. So that's the equivalent form. If we simplify that up, that would be x minus 5, minus 5 all squared plus y squared equals 31. So the center would have coordinates 5, 0. 5, 0. And the radius would be the square root of 31. Okay, then it says an equilateral triangle, that's important information, has one vertex at the origin and one side along the line x equals 8, as shown in the diagram below. Show that the vertex at the origin lies inside the circle. Well, that just means the distance from the origin to the center of the circle must be smaller than the radius. So the radius is the square root of 31. Let's state that properly. The radius of our circle is 31. Sorry, the square root of 31. And then, so 5 zeros here. The distance from 5, 0 to origin, that's just equal to 5. And 5 is less than the square root of 31. So, therefore, inside the circle. Prove that the triangle lies completely within the circle x squared plus y squared minus 10x minus 6 equals 0. So let's draw a bit of a better diagram, or add to it rather. So our circle has a center here, and it's going to do something like this if it completely contains the circle. And we can see the points that are closest to escaping are, well, this one here that we already found, and this one and this one. These two guys are kind of the same though, by the symmetry of the problem, because the center's on the x-axis. So if we prove one of those guys is in it, we can prove the other one, and then the whole triangle will be also. So if we want to do that, we need to think about the coordinates of those points similarly for how we solve the part B, part 1. So to do that, well, we know the x-coordinate is 8 just from the diagram. So both these guys are x-coordinate 8. We have another piece of information though to find our y coordinates, in that it's an equilateral triangle. So we know this full angle is 60 degrees, but that would make this angle 30 degrees. And we also know that this is length 8, just from the diagram. So we can find the opposite side of this right angle triangle just with a bit of SOHCAHTOA. So we know tan 30 is our y coordinate divided by 8. So tan 30 degrees is y over 8. Let's just quickly check what tan 30 is. Tan 30 is root 3 on 3. So y would be 8 times root 3 on 3. So 8 root 3 over 3. Cool. So now we have our x and y coordinate. So the x coordinate was 8. So for our vertices, they have coordinates 8 and plus 8 root 3 over 3, and 8 and minus 8 root 3 over 3. And our center is still 5, 0. So let's find the distance to one of these vertices. So distance to vertex, that will be the square root of the difference in the x coordinate, so the square root of 3 all squared, and then difference in the y coordinate squared, well, that's just going to be plus 8 root 3 over 3 all squared. And then let's just plug that in the calculator. So the square root of 3 squared plus brackets 8 root 3 over 3, over 3 all squared. That's the square root of 273 over 3. And let's just check that that's smaller than the square root of 31. So there we go. 5.507. 5.507. The square root of 31. What's that? Square root of 31. 5.56. So 5.507 is less than 5.56. Hence, what was that actual point? Well, that vertex is, hence our vertex is inside the circle, and other vertex will be also, because if we think about it, where does that, what actually changes? Well, it's just this minus sign, which is not going to be affected in here. So the symmetry of the fact that it's above going to below by the same distance means that it's also going to be inside the circle. Will be also inside circle as it's a reflection in x-axis. And the center of the circle, center of circle is on the x-axis. Moving on now to the mechanics section. So question 12 says, a particle initially at rest starts to move forward in a straight line with constant acceleration a meters per second squared. After 6 seconds, the particle has velocity of 3 meters per second. Well, if it's at constant acceleration, we know we can apply SUVAT. So let's just use v equals u plus at for this. So v equals u plus at. If u 0, then acceleration is just v over t. So then it's 3 divided by 6. That's just a half. So 0.5. Then we have, for question 13, a resultant force of minus 26 newtons acts on a particle. The acceleration of the particle is minus 6y meters per second squared. Find the value of y. Well, Newton's second law, F equals ma, gives us the relationship between resultant force and acceleration. So F equals ma in vector form is all we're having to deal with. If I just write that out properly, we'd have minus 2, 6 is mass times our acceleration vector. So that'd be minus 6m and my. So minus 2 equals minus 6m. That would mean m would have to be a third of a kilo. So then we'd have 6 equals a third of y, meaning that y would have to equal 18. Moving on now to question 14. It says a ball initially at rest is dropped from a vertical height of h meters above the Earth's surface. After 4 seconds, the ball's height above the Earth's surface is 0.2 h meters. Assuming air resistance can be ignored, show that h equals 10g. So it's going to be another SUVAT question, because if it's just moving in the Earth's gravity, that would be uniform acceleration. Let's just draw a quick diagram, though, to be really sure what information we've got. So the ball starts here at t equals 0. Let's say the ground's here. So its initial height is h. And then at t equals 4, let's say it's here, where this distance from the top is 0.2h, from the ground, sorry, from 0.2h is here. So that means our displacement actually is 0.8h. So let's write out what we know for our SUVAT then. So we know S is 0.8h. U, it says dropped from rest, so U equals 0. V, we don't particularly care about, so I'll just leave it dash. We don't know it though. A, if we're just under Earth's gravity and nothing else in free fall, then we just have minus g. Well, let's call it g, because I've defined down as positive for my displacement, so just positive g actually. And then t we do have as 4. And then if we want to use an equation without v, that would be s equals ut plus a half at squared. So then if u 0, that's really simple to use. It would just be s equals a half at squared. So 0.8h equals a half of g times 4 squared, so times 16. And then if we simplify that all down, it will give us the h equals 10g. Good. Then part B says, assuming air resistance cannot be ignored, so now there is some air resistance, explain the effect that this would have on the value of h in part A. Well, if there's going to be some air resistance, our general speed and acceleration, well, speed is lower because the acceleration is lower. So everything's lower. So that the distance is going to have to be smaller as well if we're going to achieve this, over the same time period, falling by the same proportion. So it's just a 1-mark question. So we'll just say h would be lower. Moving on now to question 15. It says a particle is moving in a straight line such that its velocity v meters per second changes with respect to time t seconds as shown in the graph below. Show that the acceleration of the particle over the first 4 seconds, so that's this rising section here, is 3.5 meters per second squared. So to get the acceleration from a VT graph, it's just the gradient at any point. So we'll just do the rise over the run. So the acceleration is going to be the rise where we go from -4 all the way up to 10. So that's a rise of 14. And we start at t equals 0 and get to t equals 4. So that would be a run of 4, which is going to be 3.5 meters per second squared. Then it says the particle is initially at a fixed point P. Show that the displacement of the particle from P when t equals 9 is 62 meters. So note they said displacement and not distance traveled. So if we're traveling in a straight line, as it says at the beginning, and we go from a negative velocity to a positive one, then that's suggesting that we're traveling in one direction and then we turn around. So the negative part of this graph here, that's how we're going to find area. Sorry, find the distances from the area of this graph. The negative area will cancel out with the positive area, so we have to be careful of that. To start off with, though, well, we can find this area really easily. So that rectangular area is just going to be the base times the height. So it's the run of 5 and the height of 10. So 5 times 10, that's just 50 meters. And then to find these triangles, we're going to need to find this point. So we can do a SUVAT, because we know the acceleration now, to work out when the end velocity would be 0. So if we do v equals u plus at, and we know that we're after when v equals 0, we know u is minus 4, and a is the answer from before, 3.5. So rearranging for t, we'd have t is v minus u all divided by a. So it'd be 0 minus 4, which is 4 divided by 3.5. So 4 over 3.5. Let's just simplify that using our calculator. So 4 divided by 3.5, that's 8 over 7. So now we know that that point is 8 over 7. So this area then is the small triangle. That's going to be minus 4 times 8 over 7 times a half, for half base times height. So that's a 7. Let's plug that in our calculator. So it was our 8 over 7 times 4 times a half. That's 16 over 7. And it would be minus 16 over 7 because of that minus 4. And we do care about the minus sign, obviously, from what I said before. And then the big triangle, well, the base is going to be 8 over 7. Sorry, not 8 over 7. 4 minus 8 over 7. So that's 20 over 7. So it would be 20 over 7 times the height, which is 10, times a half again. So take our 20 on 7. We will times it by 10 and times it by a half. That's 100 on 7. And now we need to bring all these areas together. So we have that plus our 50 from the rectangular section. And then we have to take away the 16 over 7 from that bit below the, for that negative area below the t-axis. So minus 16 over 7 gives us a final displacement of 62 meters like they asked for. So let's just make it clear. Total is 50 plus 100 on 7 minus the 16 on 7, which does give us 62 meters. Moving on now to question 16. It says, a toy remote control speedboat is launched from one edge of a small pond and moves in a straight line across the pond surface. The boat's velocity in v meters per second is modeled in terms of time, t seconds after the boat is launched by the expression v equals blah, 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 blah. So find the expression of the boat when t equals 2. So first thing is this is not uniform acceleration anymore. So we can't use SUVAT or anything like that. We have to think about variable acceleration. And then to get the acceleration from the velocity, we just differentiate. Acceleration is the derivative of velocity. So differentiating, we'd say acceleration is, well, 0.9 differentiates to nothing. 0.16t differentiates to 0.16. And then 0.06t squared, that's going to differentiate to 0.12t. So minus 0.12t. And then when t equals 2, the acceleration is just going to be 0.16, minus 0.12 times 2. So plugging that in, 0.16 minus 0.12 times 2. That's minus 2 over 25. Well, let's leave it as a decimal. That's what we've been working in. So minus 0.08 meters per second squared. Then it says, find the displacement of the boat from the point where it was launched when t equals 2. So to get to the displacement function, we take our velocity function and then integrate. So our displacement function, s of t, is the integral of our velocity function, so 0.9 plus 0.16 t minus 0.06 t squared dt. Then integrating that would be 0.9 t, 0.16 divided by 2, if we increase the power by 1 and then divide by the new power, that would be 0.08 t squared. Then t squared going to t cubed and dividing by 3, so 0.06 over 3, that would be minus 0.02 t cubed, and then we have to add a constant. So to find this constant, it says find the displacement of the boat from the point where it's launched. So this function is from the time it was launched. So we can say s of 0 is equal to 0. At t equals 0, the displacement was 0. That makes sense. So plugging that in, that's just going to actually go, you can see all those t's are going to cancel and you just get c equals 0. So that just is our displacement function if we just get rid of the c. So then we just do s of 2. That's going to be 0.9 times 2 plus 0.08 times 2 squared minus 0.02 times 2 cubed, and then the plus c was 0 as we said before. So we plug that in our calculator. That's 0.9 times 2 plus 0.08 times 2 squared minus 0.02 times 2 cubed, which is 49 on 25. Or as a decimal, 1.96 meters. Moving on now to question 17. It says a particle P is initially at rest on a smooth horizontal surface. A resultant force of 12.9 newtons is then applied to P so that it moves in a straight line. Find the magnitude of the resultant force. So that's just using Pythagoras on our resultant force vector. So the magnitude of F is going to be the square root of 12 squared plus 9 squared. So using the calculator, square root 12 squared plus 9 squared, it's 15. So 15 newtons. Two fixed points A and B have position vectors OA 37 meters and OB k minus 1 meters with respect to a fixed origin O. P moves in a straight line parallel to AB. Find AB in terms of k. Well, to find a position vector connecting 2 points, it's just a simple subtraction. So AB is always OB minus OA. So it would be k minus 1 minus 37. So that would be k minus 3 and k minus 1 minus 7, that'd be k minus 8. Then for part 2, it says find the value of k. So let's go back and reevaluate what we know. The piece of information we were given is that P moves in a straight line parallel to AB. And let's just remind ourselves how P moves. A particle P is initially at rest. So it starts at rest and then it starts to accelerate after this force is applied. Well, if it moves parallel to this line AB, then if we're starting at rest, the acceleration is going to have to also be parallel to AB in order for the movement to be parallel to AB and the velocity afterwards, i.e. So that's our information, really. We know that our resultant force vector, because the acceleration is always going to be parallel to the resultant force also, so the resultant force vector is parallel to this vector we found for AB. So we know that F, if it's parallel, it's a constant, let's say lambda times our vector AB. So F was 12,9. So we'd have 12,9 equals lambda times our k minus 3, k minus 8 vector. Cool. And then we can read two equations off from this. So we know 12 equals lambda times k minus 8. And 9 must equal... Sorry, that's my terrible writing there. Sorry, that's meant to be a 3 on the top. That's a 3. So that's a 3 there. And the bottom one would be lambda times k minus 8. So the top equation divided by the bottom equation is going to nicely cancel out our lambda, and we can find k. So 12 over 9 then would equal lambda k minus 3 over lambda k minus 8. The lambdas cancel. 12 over 9, that's the same as we divide the top and bottom by 3. So that'd be 4 over 3. Excuse me, let's try a bit better. 4 over 3. Then let's multiply up. So if we times both sides by 3, then we'd have 3 times k minus 3, and the 3 would vanish on the right-hand side. And then multiply both sides by k minus 8, that would be 4k minus 8 on the right-hand side. And then this is a simple equation to solve, just expand out and rearrange. So 3k minus 9 equals 4k minus 4 times 8 is 32. So minus 32. Then we'd have k is going to equal minus 9 plus 32. That is 23. Moving on now to the last question. Question 18 says, a rescue van is towing down a broken down car by using a tow bar. The van and the car are moving with a constant acceleration of 0.6 meters per second squared along a straight horizontal road as shown in the diagram below. And then we have a bunch of information about the forces on the car and the van. Let's annotate the information on. I'm just going to annotate the horizontal information because there's nothing really going on in the vertical that's going to be interesting in the question. So it's annotating the horizontal forces. There's a driving force D. There's a resistance force R. The tension would act this way on the van, and it would act this way on the car. And it would be 0.6 R acting that way on the car. And then we've got this equation for the tension. To see how this is going to sort of fit in, let's just write out some equations of motion for the van and the car, and then try and tie that in later and see if we can find the value of k. So let's start with the car, doing F equals ma going to the right. The net force would be T going to the right minus the 0.6 R going to the left. That would equal the mass of the car, which is 1620 times 0.6. And then I'm going to, just to have R on its own, I think that's going to be useful, I'm going to divide everything by 0.6. So 1 divided by 0.6, that's just 5/3. So 5/3 T, and then everything else is going to cancel out nicely. So just be minus r, because that 0.6 would cancel, and then have the 1620 there. Now let's do the van. So van F equals ma, also to the right. So we'd have D going to the right in the net force, and then we have to take away that reaction force and take away that tension. And that would equal the mass of the van, which is 2,780 times 0.6. That I will work out. So 2,780 times 0.6, that's 1668. So D minus R minus T is 1,668. And then we want to make comparisons to this now. So that's an equation for T involving D, and there's no R. So let's try and eliminate R from these equations we have here. So if I rearrange the top one for R, we'd have R equals 1620 minus 5/3 T. Sorry, that's rubbish. Other way around. It would be 5/3 T minus 1620. And now let's substitute that in here. So we'd have D minus, and then put a bracket around this so we don't make a mistake, 5/3 T minus 1620 minus T equals 1668. So then we have, if we simplify that down, we just have D, we'd have plus 1620, and then we'd have minus 5/3, and then minus another T. So that would be minus 8/3, yeah, minus 8/3 T equals 1668. Or if we try and start simplifying now, so 8/3 T is going to equal D, then 1620 minus 1668, that would be minus 48. And then let's bring that onto the next side, the next page. So steal that. Put that there. Then we need to multiply by 3 and divide by 8. So doing that, we'd have T equals 3/8 D minus, well, if we just check that it's going to pan out, it should come out as 18, I believe, from what we had before. Yeah, let's just check though. So 48 times 3 divided by 8 does indeed give us the 18. So minus 18. And then we can just make a direct comparison. So we've got T equals 3/8 D minus 18, which is there. If we make that comparison, K must just be this number here. So 3/8. K is 3/8. Then it said state one assumption that must be made in answering part A. So we have a tension involved. So if we've assumed the tension in is that applied to the car, and that is the same, it must be a not an extensible bar, a light bar. Then the tension would be the same everywhere. So the bar is light, i.e. has no mass. The bar is light. That's the end of the video, guys. I hope you found it helpful. If you did, please drop it a like, that helps me out a lot, and consider subscribing to the channel to find out when I release new videos. Thanks, and I'll see you in the next one.